Welcome to this first module of learning SolidWorks for beginners. This is an initial video where I want to cover some of the main points of SolidWorks. Now the core of SolidWorks, without any add-ins, has three real sections. If I click this little button here, it says New, it comes up with Part, Assembly, and Drawing. And these are the main things we're going to work with in this course, and these are the main things that you'll find when you take SolidWorks anywhere. What is a part? I want to start with that. You can see it's just one object, and a part can look like anything, of course. This is happens to be a piston, and these parts are generally one body. Nothing on them moves. It is a single object. So when I move on to an assembly, I can find that it is simply many parts put together. This is an example of an assembly, and here's the pistons that we just looked at. And if I go to move one with my mouse, it moves quite choppy because of my computer graphics, but you can see that it moves like it would in real life. The valves are timed to the pistons like in a real engine, because we can define relationships between parts in an assembly to constrain them in the place that we want them to be and to move in the way that we want them to move. So this is an assembly, essentially many parts put together. So what is drawings that you can do in SolidWorks? Well, let me show you an example. In SolidWorks, you can use drawings to show exploded views, to identify components. You can take dimensions and make technical drawings that way. Drawings give you the ability to set specifications for parts and assemblies, to define what you can accept and reject on the basis of quality. So drawings are very useful. In this course, we will be going over parts, assemblies, and drawings in a way that is adequate for you to prepare for the CSWA exam should you want to take it. That is a fundamental exam that shows that you have experience and skills in SolidWorks. Okay, up here, this top menu, you have a little pin here, so you can unpin or repin the menu that has File, View, Tools, and Help. I leave it pinned down because I like having that extra functionality. You can click on this guy for a new if you want to make a new part, assembly, or drawing. You can open, save, print, undo, select, rebuild, go to File Properties, Options, and this is a macro that I put up here that exports PDF files. So this is just my thing that I've added. In the options section, it covers just about everything. One of the things that I like to do is go to Colors, Background, Dark, OK. It gives it kind of a nice dark theme. It's easy to look at dark colors, and dark colors on a screen saves a little bit of power too. Over here on this menu to the right, you can click on the house, and it gives you Home with SolidWorks resources. It gives you the opportunity to make a new document like we went over before. Open a document, tutorials, do some online training, a few other resources that you really don't heavily use very much. SolidWorks RX helps you track errors and even record your screen if you're finding a recurring problem. You can go to the design library where they have some links to the web, and that you can pull solid models, gears, things like that off the web if you want to. You can find some extra SolidWorks content. These are for drawings. It helps you make some preset views of your parts, which we will go into in the drawing section of this course. This is for appearances, and it can help you apply certain colors and textures to a part. And you can go to custom properties or SolidWorks forum, where you can post questions and have other forum members respond. This is just a quick run through of the features that you will find when using SolidWorks for the first time, and we will be going through these in a greater amount of detail as we progress through the course. Alright, so in the next video we will get into the environment where we will work on making parts. See you then. Welcome to this installment of the SolidWorks course. I want to go over how to make parts in SolidWorks to begin with, and in order to make parts one has to learn how to make a sketch. Sketches are the basis of just about anything you do in SolidWorks. They generate parts, assemblies, drawings. It all comes back to skills in sketching. So to start off by making a new part, I'll go to the Open button right here, click on Part, and OK. And this is the view where we can begin sketches and making parts. Notice we are given in our left-hand history tree over here a front plane, a top plane, and a right plane. Planes are perfectly flat and perfectly infinitely thin. And so we can choose any one of these to sketch on. To make it easiest, if you orient it so that the front plane is generally the front or side of the part and the top plane looks down on the part, it will be much easier to work with when you make a drawing. So especially if the top plane is looking down on the part from the top, you're doing great. Let me give you an example of a part that I might want to make here. This is a tape holder, for instance. Maybe we can make one of these in SolidWorks as an example. So here are the basic tabs in SolidWorks. In this environment you have a features ribbon, which we won't use for sketches. We'll get into that later. You have a sketch ribbon, which we will pretty much exclusively use. You have a surfaces. Surfaces is more advanced, so we will not be doing that in this course. It's a great skill to learn if you're interested in smooth, organic, curvy shapes in SolidWorks. You have an Evaluate tab, which can let you measure a solid, which we'll be getting into how to do solids later in this course, and tell you the mass of your part, where the center of gravity is, etc. And a few other tabs that aren't relevant to this course as well. So if I go on the sketch ribbon, and I have my history tree right here, so this gives me all the things that I've done while making the part, I get to choose a plane. Now when I pull up my tape, let's say I want to start with this side of the tape. And learning SolidWorks, the more you do it, the easier it is to learn what you want to sketch first. I'm going to make an outline of this curvature of this side. So going to SolidWorks, I'll choose my front plane. And to get the front plane to face the screen like that, I just simply click on the front plane and press Ctrl 8. From there, with the front plane highlighted, I push the sketch button, and we're ready to start. The first thing is that I have these 9 options to sketch with. The first thing is I can click on the line, and I can click once, and SolidWorks starts making a line. I can click again, and it finishes that line and starts another one. If I'm done making lines, I just double click, and I've got my line there. Or of course I can just keep making lines by moving my mouse and clicking if I desire to. Of course I can highlight any line segment and push delete to get rid of that line. So I can make lines in SolidWorks. Here I can make rectangles. I can click once, then click in another place, and I've made a rectangle. I can make a circle here. I can click anywhere and click anywhere again, and I've made a circle. 3-point arcs, those are fun ones to work with. They're one of my favorites. I can click in any 3 points on the screen, and it gives me a section of a circle, or an arc as we say appropriately. Here I have a straight slot. I do not use this one very often, but I can make a line, and then I can click again, and it makes a slot around that line. It's useful if you need a slot. I don't use it very often. You can also make a polygon. Good for making bolts, I guess. Finally, these guys over here, you have a spline. This is not often used in a sketch, but sometimes it's very useful. You can just keep on clicking over and over and over, and it gives you an organic, smooth tangent geometry. Splines are not very useful when you have like 100 points unless you're going for something that you don't need to constrain. You have an ellipse, which you start off by making what looks to be a circle, and then you can choose how eccentric that ellipse is. These are all very basic sketch tools. And then you have a sketch fillet. A sketch fillet has to be done with existing lines. So if I make 2 lines and I want to have a smooth curve between these 2 lines, I can grab this fillet and it can make a smooth curve. Let's say we give it a radius of 1/2 inch. There it is. So that's a sketch fillet. It takes a sharp corner and makes it smooth at any radius you specify. So now that we got these tools, how am I going to make this tape? Well, what I'm going to do is go to this red guy. This is called the origin. And if you notice, I've got my front plane, which I'm sketching on. If I move this front plane at an angle, the little scrolly wheel that the mouse has, you just push straight down on that scrolly wheel, and as you move your mouse, it changes your view like that. When I look at this at an angle, notice I have my top plane and my right plane, and that red origin is where the 3 planes intersect. And that's very significant on using the origin. Again, I push Control 8 to get that front plane, what we say normal to me, or on that straight-on view. When we use the origin, it will be very significant in the next video. So I'm going to make a horizontal line. This will be the bottom of our tape holder. I'll make another line. This is just a free form, completely unconstrained, thinking that maybe this will look a little bit like what our tape looks like. Now I'll add a 3-point arc where it will go down to hold the tape. I'll add another line and straight down. So this, I'll even go a little bit more detailed and give it kind of an edge right there. So if you notice, this tape looks a lot like if I'm looking at just this side straight on. This is kind of what the side view would look like, and that is the goal of most sketches. You pick one side and you make it look exactly like that side view. Why you do that will start to make sense in the next few videos. I could choose this side to make, and that would be a little bit more rectangular looking without any arcs. I could choose what it would look like from the top and sketch almost a complete rectangle. There's no right or wrong way. You generally with a sketch will choose one side and make it look like that view straight on. In this case I chose this side. Some views will be easier than others. It just takes experience to learn which, and this will again start to make sense in the next few videos of what I'm talking about here. Also notice that now that we've made a sketch, our history tree has a sketch in it. If we were to make another sketch, that sketch would show up below this sketch, and so on and so forth. So every feature or sketch you make shows up in this tree. And you can go back and make changes to those as you go along. If I look at this traffic light guy right here, this is the rebuild button. You can also do Control B. B as in beta, or you can Control Q as in Quebec, and Control Q forces everything to rebuild. So it's a more thorough rebuild if you think about it that way. And when I rebuild the sketch, SolidWorks goes in and makes everything all over again. When it's rebuilt, you notice it turns gray. This is what we call an inactive sketch. So an inactive sketch is gray, just like this. And you cannot edit an inactive sketch. So if you want to make any changes, choose any part of the sketch, right click and choose Edit Sketch, and it brings you back into a place where you can edit that sketch. But of course, I don't know if this measures 100 feet long or an inch long, and it's important to be able to make the model the dimensions that I want. So now that we have tools where we can make circles and lines and rectangles, let's, in the next video, talk about how to give our sketches dimensions. So I'm going to wrap it up here. Before the next video, get familiar with the sketching environment. Try making a few sketches, pick out things that you like, things that you don't like, and we'll resume on how to make these sketches in a controlled dimension in the next video. Thanks for watching. Welcome to this next installment in the SolidWorks course. This topic is about relations. What is a relation? You'll notice, especially probably in last video, I've got some black lines, some blue lines, some blue points, and one black point. What does black and blue mean, and what are these green things that pop up when I click on a line? Well, I'll start with the black and blue. Notice that this line, I can make it whatever angle I want to. But this line, when I click on it and move it around, it stays horizontal. So when you have something that's black, SolidWorks means it is defining its position. In other words, when I click on this horizontal line, I've got this little horizontal green guy with a horizontal black line running through it. That means that SolidWorks is going to do whatever it takes to keep this line horizontal. How do I get relations? Well, if I were to add a line on the origin, what is that little yellow thing by my mouse? That is a horizontal relation. So when I click, SolidWorks has added that relation automatically. So if I add a line and I've got that yellow vertical guy, it means that SolidWorks is going to keep that line vertical if I click right there. If I click at an angle, it won't. If I click here, it adds an automatic horizontal relation. Here, an automatic perpendicular relation to this orange line up here. You can see how that line glows orange. When I move it to that position, it means it will stay 90 degrees to whatever that orange line right here is doing. Okay, so we see that SolidWorks can add relations automatically depending on what position I create the line in. But what if SolidWorks doesn't have this horizontal relation? What if I want it to be horizontal and it isn't? Well, here's how to add it. I can click on this line and say horizontal. And now I've added a horizontal relation. And I can do that with any line. I can add this line horizontal. Or, if I wanted to, I could add this line and say vertical. So there are all sorts of relations that I can add to a sketch. And now you know horizontal and vertical. One very important one is often when I have an arc and a line, I want the line to go into whatever angle the arc is when it ends, so that it is nice and smooth. But I can't just drag it to be where I think it would be, because there's always going to be some imperfection. So to make sure that it's perfect, I can select the line, hold Control, and select the arc. With both of those selected, I can choose a tangent relation. And now SolidWorks will make sure that this arc and this line will always be tangent. With that being said, What if I wanted this line right here to line up perfectly with this line? Well, there's a relation for that. I can choose these two lines and say collinear on the left-hand menu. And collinear will make sure that these lines will always be at the same level. I don't want them to be collinear for this sketch. I want this line to be just a hair lower. Okay, so now you know vertical, tangent, horizontal, and collinear. What if I wanted to modify this sketch? I will delete that, and I'll add in a line here and up. I can move this over, move this down, and make this vertical like we talked about before. But what if I wanted this line and this line to have the exact same angle? One easy way to do that is selecting both lines. I choose parallel. And now, with the parallel relation, these lines will always have the same angle, even when it messes up my sketch a little bit. Notice I can also make this line longer than this line. What if I want two lines to be the same length? I can choose this line and say equal in the left-hand menu. And when I say equal, well, I can highlight both lines and in the left-hand menu say equal. And now they'll always be the same length and angle no matter what I do with the sketch. Likewise, if this line wasn't vertical and I wanted to make sure that two lines were always 90 degrees apart, I can select both of these and say perpendicular. And now SolidWorks will make sure that these two lines are always 90 degrees apart. Since this line is horizontal, we know that this line must always be vertical. What about some arcs? What if I had a 3-point arc and another arc? Well, there's a few relations I can make there too. I can make one arc and another arc. I can select one arc and another arc, and I can choose concentric. And that means that no matter where this arc is, they will always share the same center point. Likewise, if I delete, I can choose equal, which means that no matter what happens with the sketch, they will always be the exact same radius. As I mentioned in the last video, I want this tape to be certain dimensions, this tape holder. I don't want to find out that I modeled this to be 10 inches long when I meant for it to be 6 inches long. So I can start dimensioning things. Now notice up in the sketch menu I've got this little icon that says Smart Dimension. That is the best way to dimension anything in SolidWorks. Now I can dimension from the origin to this line to get an overall length. Let's say I want that to be 6.75 inches long. Now SolidWorks, whatever I do with this sketch, will keep this line to always be 6.75 inches away from this point. Likewise, I can determine a height. I can say from base to this point, I want it to be 1 inch tall. You notice that as SolidWorks changes the dimensions, sometimes the sketch changes as well, and that is completely fine. Okay, there we go. Let's say that I want from here to here to be 1/2 inch tall. So this line will always be 1/2 inch taller than this line. And likewise, I can define an angle here. Maybe we should say 60 degrees. And I can define a radius on this arc, 5.5. I can make this 1/2 inch. And notice as I'm dimensioning these things, more and more of our sketch is turning black, which means that SolidWorks knows exactly where these things belong. If I have any question as to what is not defined, I can simply grab something blue and move it around. And if I say, this line changes length when I move this up and down, so I have to give this line a certain length, or at least define where the blue point is. So I'll make it 1/2 inch. How is this arc not defined? I should put a dimension here. So I'll make this 2 inches long. And now everything is black. So we've totally, completely defined our tape holder. Okay. There may be some problems that you'll come across having one of these sketches. What if I make this 270 degrees? Well, all of a sudden, SolidWorks turns yellow and red. It doesn't like it. And what it's saying is, it's saying, hey you, if I have something that is 1/2 inch long here, and I try to make this line 270 degrees, well, this line has to be the same length. This line has to be the same length as this line, and I can't make the sketch physically work if this is 270 degrees. So that's what's called being over-defined. And there's some options here. I can hit the Control Z, which is Edit Undo, and that undoes the sketch and fixes everything. In addition to that first solution, you can also see where it says no solution found in red letters along the bottom. Click on that, and a left menu comes up that says press Diagnose to find solutions to the sketch error. And by clicking Diagnose, it comes up with some proposed solutions and what the sketch would look like. So I can choose to accept it or move on. It has 25 different ways that the sketch can be fixed. Clearly this looks nothing like what we want, and so I don't find this to be a very effective option unless I'm desperate. Yeah, no real great solutions there. But if there's one I like, I can hit accept and then reconstrain it in a way that I don't have to worry about. Notice the things in red are usually the things that are more likely to cause the problem. The things in yellow are more likely to be affected by what the problem is. So if I change this back to 2, we're solved. So if you see red or yellow, you'll know that the sketch is over-defined, and you can hit Control Z to fix it, or you can try to change other dimensions or anything else. But the takeaway is, when you're over-defined, the sketch cannot physically be possible. With that being said, quick review. We learned horizontal, vertical, tangent, parallel, equal, concentric, all these great relations. You may need to watch this video a few times to absorb exactly how these relations work. And in the next video we'll do some more sketches that cover some examples of how to use these relations. Thank you so much for watching, and I'll catch you in the next video. Welcome to this next installment in the SolidWorks course. I wanted to reinforce some of the constraints and relations we learned last time. So this will be an example of how constraints and relations can work further than what we've already done. I have the solid in SolidWorks, and I wanted to generate the sketch that would produce this as a means of giving some extra practice and reinforcement to the sketching skills we learned in the past 2 videos. This is one of the most important skills to have in SolidWorks because everything else comes from sketches. So, without further ado, I'll start a new part. I'll sketch on the top plane this time, and I'll push Control 8 to get normal to it. And hit the sketch button. Now, I'll do horizontal line. Oops, and when I double clicked it, made a few other lines here. Now I'll do a vertical. Double click to get rid of the line. Horizontal, double click, and vertical. So the question is, how can I get these lines to be constrained in a way that it would look like these 4 lines on the outside of the part. Well, to do that, I'll use what we call construction lines or center lines. I'll choose the center point of each line. You'll see when I hover my mouse close, it just pops right up. And I'll select the midpoint, and I'll select the origin and say coincident. Then I can just make this horizontal. And now both of these lines will always have the origin at the center, and their centers will always be horizontal because of this reference line known as a center line. You know center lines because they're dotted, and they're only used for reference. They're never used to make a finished product. But we're referencing off these center lines. So now notice when I move this line has a constraint on it. We don't want that, so I'll delete it. And now I can move this without this line moving as well. Now I'll choose a center line, center and center. From that, I'll select the midpoint and put it right on the origin, coincident. I'll make this vertical. And now notice I have kind of a rectangle, but if I make these lines equal, now we have a square no matter what length these lines are. I've done a full constraint on these. Finally, I can select these 4 lines, and I can choose equal. Oh, select this one too, equal. So now all 4 of these lines change length together because they are equal length. Alright, with that being said, I can add again some center lines if I wanted to. And this is again only used for reference. And in fact, just to help constrain things, I'll put some dimensions down here. I'll make this 6 inches long. I'll make this, say, 4 inches. And I can make a 3-point arc. And I can use this point created by the center lines. I can select the midpoint of the arc and that point and say merge. And now we know that the middle of the arc will always be at the intersection of this line and this line, which is what we can observe in this model. That being said, I can add another 3-point arc, and I can start adding some relations. And I'll put another arc over here. First one, tangent. Second one, tangent. Third one, tangent. And tangent. Excellent. Now all I have to do is give it a dimension. I'll make this 2 inches is a bit too big, so the sketch physically will not work out if I give that a radius of 2 inches, so I'll give it a radius of 1. Still not working. There you go, 3/4 of an inch seems to work. So there's 0.75. Now on this next corner, maybe I can save a little bit of time. So I'll make a 3-point arc again. And instead of drawing my center lines, I can simply choose the center point and this vertical line and say coincident. So now the center point will always be located along this line. And then I can locate it this way on this line by saying coincident. So now the center point of the circle can't go in, or the arc can't go anywhere because it's on this line and this line, so it's fully constrained in that sense. So I don't have to make these center lines, I can just make it coincident if I wanted to. Again, adding in these 3-point arcs. I'll add the same constraints and relations and say tangent, 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 tangent. And giving it the same dimension of 0.75. And we're fully constrained. So you can see we have identical pieces, could be a straight mirror image. And we've done less work here. Well, what if I could save further time still? What I'll do this time is I'll make a 3-point arc and put it directly on these 2 points instead of adding these fillets over here. And I'll make it coincident, and notice this arc is fully constrained. And then I can use that sketch fillet feature that we went with, and I can make this 0.29, and then I can do it the same thing on this side, 0.29. And again, we have done even less work, and we've ended up with the same result. So I'll go ahead and do that again. This is to illustrate that you can do several different things in SolidWorks and get the same result. So now we're done with our sketch fillets. Now, I recall having some holes. So we've got some holes at the centers of these arcs and one in the middle. I can go ahead and add that. I'll add 4 holes, varying sizes. I can select all 4. And say that all 4 should be equal. I can give them a dimension of 1/2 inch, and there they are. And finally add 1 in the center. We can make that 5 inches. And there's the sketch that can make a part that's similar to what we see here. The idea behind sketching, of course, is that everything should be fully constrained. In the industry, especially in engineering, when you have a sketch that isn't fully constrained, it's not taken very seriously, and it's not trusted, certainly. So the mark of a good engineer is fully constraining every sketch, making sure that everything is black. And when you've done it, SolidWorks will tell you fully defined down here, so there's no question. So I hope this was really helpful in seeing how constraints and relations and tangents and being cocentric and coincidence all work together to fully constrain a sketch. Being able to use these relations can sometimes take a lot of thoughts, especially effectively using construction lines. So keep practicing. There's plenty of resources that help with sketching. And in the next video, we'll cover some of the very, very last sketching skills, and then we'll start making solids. See you next time. Welcome to this next video in the SolidWorks course. I'm going to go over the final sketching skills that would be helpful to know before we start creating solids like this one. Here I've got a 6-bolt flange, and I want to go over a few ways that you can make the sketch for this. I'll take the most simple one first. That will be a little bit more work than you would need to otherwise, but this will probably be a good example in how to make sketches in several different ways, and if you're still working on sketches, this could be helpful. I'll make 3 circles. First one will be the OD of the flange, or the outer diameter, and we'll make that, say, 6 inches. We can make the inner diameter, say, 3 inches, and I'll make this my bolt circle, or the circle that all the bolt holes will be on. My bolt circle, I'll make 4.75, and I can highlight this circle and make it for construction. Just like those construction lines that we've been working with, any construction geometry is for reference only. And so I can reference the location of all the bolt holes. The first one, I can snap it right to that point on the circle that is perfectly horizontal to the origin. I'll go ahead and make that hole 1/2 inch. I'll make 6 more holes. If you noticed, SolidWorks made this vertical with the origin. I don't necessarily want that, so I'll delete that relation. Now I'll add a series of center lines, because if you'll notice, I snapped these holes onto the construction circle, but I need to define an angle that they can be equally spaced at. So I'm going to use a center line. You'll see also SolidWorks automatically made this a vertical line, and I don't want that, so I'll delete that relation. Now, I know I've got 6 bolt holes that I want evenly spaced, and I know that a circle is 360 degrees, and I know that each circle then should be a sixth of whatever the full circle is, so I'll say 360 divided by 6, and I can do that for each hole. And I've got one extra. I made one too many. So here I've got 6 bolt holes. Notice they can vary in size. I'll select all of them and choose equal. Now we've got a fully constrained sketch, and this will produce the flange that we have seen before. Now, what are some easier ways that we can start making these? Well, I'm going to go back and go through another method that I believe takes a lot less work. Notice when you go to delete something in a sketch, sometimes you'll see this box come up in SolidWorks. This is telling us that if I delete a construction circle, I'll be deleting certain relations or dimensions along with that, and that's fine. So I'll say enter. An alternative way to deal with this is I can make a hole, or in the sketch a circle, click the center point, click the origin, choose horizontal, and then from the origin to the center point I can make that 4.75 divided by 2. That's the distance of my bolt circle. I can make this 1/2 inch, and I've got a fully constrained hole. Then I can go to my sketch menu up here and choose Circular Sketch Pattern from the menu. And it asks me what parameters. I can choose I'm going to click Entities to Pattern and click this circle, and it automatically fills in point 1, which is right here. So it knows it should make a circular pattern around this point. But you can always specify something else by highlighting and say clicking this circle, which also generates the center of that circle being point 1. Now I move the quantity up to 6, and notice equal spacing is checked. That makes sure that every single one of these circles is equally spaced. I can click the select button and I've got a sketch. Notice these aren't fully constrained because they're blue. If I go to drag one, you'll see that the center point of the pattern is not constrained. So I select the origin, make it coincident, and we've got a fully constrained sketch right here. So we've made the same sketch with a lot less effort and a lot less dimensioning. While we're on the topic, I'll come up with another sketch for you. I'll make a rectangle, and I'll dimension that to be 6 and 10. So with a 6 by 10, I can make one circle. And let's say that I wanted to have an array of circles going horizontally and vertically all along this part. Well, instead of having to do all of those, I'll just make a 1-inch circle, and I'll constrain it to our already fully constrained rectangle. Then I'll choose from the menu Linear Sketch Pattern. Notice it gives me an X and a Y. All I have to do is choose Entities to Pattern, and it already starts by patterning in the X direction. So I can change that quantity, and notice they're overlapping. To prevent them from overlapping, I'll increase the distance to say 1.5. And I can keep on adding to the pattern until I'm satisfied. Then in the y-axis, I can also up the quantity, and I can make the spacing probably 1.4 or whatever dimension I want, because we're the engineers. That looks pretty good. And again, things are not fully constrained, and that's because the distance in between the entities just needs a dimension. So I'll use the dimensions that we've used before. There we go. Of 1.5 and 1.4 in the y direction. Notice we're still not fully constrained. So, to constrain that, notice that they just don't know if they should be vertical or what. So I'll grab 2 points and ensure that they are vertical. And we're fully constrained. Anytime you have a question as to why something isn't fully constrained, just drag it around and you'll find what's not fully constraining, and you can deal with it from there. So that is linear sketch patterns, and you can do it in the X direction, in the Y direction, or both. And you can do it at an angle. And if you wish to do it in an angle, you can say linear sketch pattern, and down here display, say something like a 45-degree angle, and you can start patterning in whatever direction you want. So something like polar coordinates that you'd learn in Calc 3 or something like that. Okay, so back to the flange. I want to share one other thing with you that will come in handy in the future. I'll model the flange using this method, and this is not by any means the easiest way to model this flange, but it's something that will be very handy in some situations that the circular and linear patterns won't be handy in. So I made a midpoint line simply by grabbing the midpoint line from the menu. You can choose where you want the midpoint to be, and then the line will work from there. I'll give that a dimension of 6 inches. I can make this a construction line by not dimensioning it again, but by clicking on it and clicking the for construction box here. I can make an arc. Now, I want this arc to end at a horizontal. To do that, I'll do another center line. And I'll make it tangent to a horizontal construction line. And we're fully constrained. Notice this is not fully defined, but because it's for reference only, it doesn't have a bearing on the finished product. So SolidWorks still tells us we're fully defined down here, despite a construction line not being fully constrained. I can add another one. And I don't have to make this one horizontal at the end because I can make it concentric. And when I make it concentric, I have no ability to move it off the center because this circle and this circle share the same center, which means that they'll both be horizontal at the same point. I can give it a dimension. I'll give it 3 inches. And I'll make yet another, our bolt circle. And I can give it the same relations of being concentric, and adding in the bolt circle dimension of 4.75. And for construction, astute viewers will see that I am making half of a flange. I can dimension these. And I can make this horizontal. (60°), which is a 1/6 of 360. Dimension on the hole. And now I can make these circles all equal. From here, all I have to do is go up to Mirror Entities and ask me to select the entities to mirror. I can grab the 3 circles and the inner and outer arcs, and then I can mirror about this line. And it automatically completes the circle for me. As I completed that, some of the dimensions were lost, so I'll have to reconstrain it by adding a 6-inch and a 3-inch diameter. And if there's any question as to what else isn't fully constrained, I can simply grab something that's blue and try to drag it somewhere. We're not fully constrained on the center, so I can grab this center point and make it coincident on the origin, and we're fully constrained once more. So we made half a flange and we're able to make a full flange from it using the mirror features. Some of the circular patterns will be even less work, but there will be times when mirror is the best option when making a sketch. You'll notice how handy the construction geometry is, because nothing in our finished flange will have anything to do with this line or this line or this line or this line. It will just look like a flange. So the construction geometry is phenomenal for being able to reference a bolt circle without having a bolt circle anywhere in the finished product. And that's why these are for reference only. Well, congratulations on making it this far. We'll start making solids in the next video. See you then. Welcome to this next SolidWorks course installment. Today we'll be making some solids. So here I've got our old friend, the tape holder, pulled up, and let's go over how to make a solid with it. First off, you have things on the sketch ribbon, and all of these are dedicated to generating sketches. To make solids, the features menu is dedicated to generating and modifying solids. Probably the simplest way to start making solids is the Extruded Boss base. So you see we have a sketch that is what we call enclosed. I can go all the way around and there's no breaks in the border. The whole thing is enclosed. Now SolidWorks 2017 shows us an enclosed figure by highlighting the center, this kind of purplish color. SolidWorks 2016, 2015, 2014 doesn't have that feature, so the inside will be the same color as the outside. It's not quite as easy to recognize something that is enclosed. But if you're dealing with something enclosed, at least in 2017, you have this to tell you. So to make this solid, and it is easiest to make solids out of enclosed sketches, just hit the Extruded Boss base button, and you can see it automatically recognizes the enclosed sketch. And if you understand the extrusion in the manufacturing process, this is just like extruding when you manufacture. It's pushing a solid out of the sketch plane in the shape of whatever enclosed sketch that you have. So you can specify how far you want to extrude it. I'm going to do 1.25 inches. And it gives us certain options here. I'll go through these in just a minute, but right now it defaults to blind, so I'll do a blind extrusion. And we have a solid, and I can use that center mouse button wheel to rotate our view and look at the solid that is generated from this. Maybe I can extrude a few other things. If you remember our good friend the flange, we made this in an earlier video, we can extrude this as well. You can see that when I have an enclosed figure within an enclosed figure, it gets darker in these spaces. So if I hit the Extruded Boss base, it automatically recognizes what I want to do. Now let's say I wanted to do something different. I can go to selected contours and say nope, I want to do just this, and it will extrude just that hole, and the rest of the sketch will be irrelevant. Or I can choose these if I wanted to. So I can choose whatever contours I want to extrude. Of course I intended for it to be this. So when I extrude this flange, maybe we'll make it 1/4 inch plate. There it is. And hit the check mark. There's our flange. Pulling up the tape again, let me give you some other examples of ways you can extrude things. When I hit the extrude button, notice it is from the sketch plane. In other words, my sketch is on a plane. In this case, it is on the front plane. So it's saying push it out from the front plane. So this covers where you're extruding from. This covers the actual extrusion. So I can go ahead and switch which direction. Let me make that extrusion longer so you can see. Do I want to extrude on this side of the plane or this side of the plane? And what distance do I want? 1.25 perhaps. I can also choose something like mid-plane, and that does both sides of the plane. That is a very, very good one to use. I wish SolidWorks would default to the mid-plane, because when you go to add a feature on one side, you can mirror it across this plane to the other side, which we'll be going over later on. So mid-plane is probably the best way to make an extrusion, in my humble opinion. You can also go up to vertex, up to surface, offset from surface, and up to body, which I will be covering shortly. So when I extrude this mid-plane, boom, there we go. Now the great thing is I can choose other things to sketch on that aren't planes. I just need a perfectly flat surface. Notice this is a perfectly flat surface like a plane, and so is this and this and this. This is not a perfectly flat surface, this is a curved surface. But just about any other surface I can choose to sketch on because they're all flat. So if I want to make a sketch, I can sketch on this plane and say, go to the sketch menu and say sketch. And now, whatever lines that I make, they're projected on the plane of that surface. So anytime you're working with a solid, you can sketch on these parts and it would work. Maybe I can complete this sketch because we need a place for the tape to sink into. So if I can click on this surface and push Control 8, and I can start sketching. Notice, just like in a regular sketch, I can go to a surface and it will show me the midpoint. So I can make a construction line that attaches to both lines' midpoints and make it horizontal. And that shows that this whole sketch will be in the middle of the tape holder. Now, I can give this a dimension, perhaps 3/4 of an inch, and I can give this 1/4 inch, and I can give this, what do you say, 4 inches. I can extrude, and this will be a very good example of some of the things you come across when you extrude. Now, we just did an Extruded Boss base, this guy. And what we did is we added material from the sketch. We can do an Extruded Cut, which is the same thing except it takes material away. And what I want to do is make a place for the tape to sit in, so I can use the sketch to cut into this tape holder. I choose Extruded Cut, and it gives me a certain distance. Let's say I want to go a 1/2 inch deep. We'll probably want to go something more like 1 inch will be the height of the thing, so we'll go 0.75. And we've cut into the figure. Now, a few things to observe here. First, I've got this little lip. And why do I have this lip here? If I go back and notice, I should point this out as well, the history tree, every time we make an extrusion, records the fact that we've extruded the body of the tape and that we've made a second extruded cut. And under the Boss Extrude and Cut Extrude, you can click that little arrow and it gives you the sketch that we made. So there's our sketch, and if we have to change anything, you can right click and choose Edit Sketch on the menu. So if I do this Cut Extrude, right click, Edit Sketch, I can make any changes I want to the sketch that I just made. I'm happy with the sketch, but as you can see, the sketch goes into the solid, so when we cut downward, this little top is still here. So let's go over some ways that we can deal with that, because there's several ways that I can get it to cut in both directions. I'll hit this Rebuild Traffic Light, which will automatically re-extrude what I just my extruded cut. And if I want to change the way that I extrude, I can go to this Cut Extrude, right click, and say Edit Feature. Now, so you can see what's happening. The sketch goes below that surface, and so we are not cutting that top surface. One way to deal with this is to say from blind to mid plane, and then I can just make it deeper, 1.5, and so I'm cutting in both directions to about the same depth that I was before. This is not ideal, because what if I have something above here? It works in this part, but if I have something above here that I don't want to be cutting, and I end up cutting it because I have to make it so large to go as deep as I need to, that it might not work out. So I'll go back to blind. I'll go back to 0.8 7.5. So if a midplane doesn't work, I can go and select, or I should just check this box and extrude into another direction. And I can change this direction independently of what I'm already extruding. So I can always choose direction 2, and that gives me that nice edge that I'm looking for. Another thing I can do, if I don't want to do that, let's say I have to hug this surface. Well, I can say up to surface, and I can choose this surface, and it will only cut and stop right at the surface. So that's a pretty good one too, because then I'm not really going above my sketch plane at all, except for hitting this surface. Maybe I can give you another example on that. If I sketch here, and I'll go Control 8, and whatever sketch that we do, it's always important to make sure that it's fully constrained, because nobody will trust a sketch that isn't fully constrained. We'll go ahead and dimension that to be, say, 1/2 inch by 0.6 by 1.5. What I can do is, if I wanted to add a ridge, do a boss extrude where I add material, I can say Features, Extruded Boss Base, and I can choose up to surface like we did before, and it only extrudes on this surface and nowhere else. It doesn't go into the body or anything. So it's a very clean way to extrude things, if I wanted to add that little feature there for some reason. Now, we've covered up to surface. Up to vertex is also a very similar thing. Whoops. I'll just edit this feature. When I choose up to vertex, so if I choose up to vertex, I can choose an edge, and it extrudes down to the level of that edge. So if I clear that, and I can choose this edge if I want it to go a little bit deeper. So a surface is a face like, I should say surface is a face like this. A vertex is an edge like this. Up to next enables us to extrude up to the next feature, which in this case it automatically detects as this face. So up to next is basically up to surface, but it automatically chooses the first thing that the extrusion runs into. Through all goes to the very, very end point of the part. This is especially handy when doing an extruded cut, because you can cleanly cut through the entire part without having to specify a certain length. Offset from surface says if I want to go, say, 1/4 inch above this surface, or 1/4 inch above this, but I don't want to have to do the math or measure it out, I can simply say 0.25, and it automatically stops 1/4 inch above this bottom surface that I specified. So that's offset from surface. And up to body, it chooses the entire part, and it extrudes only to the entire part, or the entire body itself. That is all the different ways that you can extrude. Another thing that I can do if I want to is I can change from the sketch plane. I can choose offset, and that means I want to go 1/4 inch above what my sketch is. Well, now I'm extruding from a quarter inch above this sketch onto the body. What I can also do is blind it and go down into the body, or I can say, and this is an interesting thing, when I choose up to surface, it continues the curvature of the surface without going onto this face because I only specify this surface. I can't choose two, it only lets me choose one surface on up to surface. So that's where up to body fits in, because it will allow me to do multiple surfaces on a single body. I can also extrude from a surface. So if I choose this surface, then it will move the sketch onto this bottom surface and extrude from there. It's kind of a more simple way of saying offset, because I can choose the surface that I want to offset onto instead of calculating out a distance. Vertex is the same thing. Remember, vertexes are more like edges, so I can choose the height of that edge to extrude from. So that's extruding, and that is just about every extrusion feature you could ever want. If there's any confusion whatsoever, just stick with blind and mid-plane, and as you play around with some of the other extrusion options, it becomes pretty clear how they work and what to do. Join me next time, and we will cover another way of making solids. See you then. Welcome. In this video, I would like to go over certain aspects of the 3D environment that we can now go over because we can extrude now, and also another way to make solids. You can see that I have my friend the tape holder here, and I have that ledge that we talked about in the last video. If I want to get a closer look at this ledge, it's helpful to know how to do that. Well, I have certain view controls up here that will come in handy now that we've got solids. The first one is zoom to fit. If I've got a solid way out here, I can click this zoom to fit button, and no matter where or what orientation the solid is, it zooms to be the perfect frame. I can also do a zoom to location. So I click this button, draw a little square, and it zooms to that little square that I choose. Pretty simple. And I've got this button, which just takes me back to the previous view. Again, very handy. I have this button, which is probably my most used on this menu. It's the section view. Now notice we have 3 planes that we start off with, the front, top, and right plane. And I can section it out parallel to any of those planes, or any other plane that I artificially create. I can take this plane and drag it parallel to the front plane at any point, and it cuts the section, or it cuts a section out of the solid so that I can view that ledge, for instance, a lot more clearly. And it can make views that are hard to get otherwise. So when I click the section view, I can be parallel to the top plane and move that up and down, and at an angle if I so desire. Or it can be parallel to the right plane. So I can get just about any section view that I want to. I can also choose a face, so I can choose this face and it snaps to that face. I can choose this face or this face. Any flat face I can snap to make a section view out of, which can also be very handy. This menu handles views. So this is clearly the top view. This view is the front view, the left view. So you can get normal to any side of this part. Okay. So these views, or the orientation menu, you can bring the top, front, left, right, back, bottom. So you can click any of these and it will take you to that view to help you orient the part. Also, you can go with an isometric view, which is also very handy. You don't have to use this menu, however. You can push Control 1, 2, 3, 4, 5, 6, 7, and 8 to access all of these views. Now remember, Control 8 is normal to something, so if I choose this face and push Control 8, I become normal to that face. This face, Control 8, I become normal to it. This face, Control 8, become normal to it. So Control 8 is normal to anything, and the rest of the controls are for specific preset views. And that's why it's so important to orient the views like we talked about in some of the first videos according to the front, top, and right planes so that the part will orient correctly the way you intend. This menu enables me to change the appearance of the part so I can get rid of some of the hard lines, and notice no tangent line here anymore. Tangent line here, and it's gone. So this view can make it for a little bit more of a realistic rendering. It's called hard lines removed. Now I can do this hidden lines removed, and this is a view that enables me to look at the part without any shading whatsoever. I can go down to showing the hidden lines, and this shows me the interior surfaces of this feature, or this extruded cut that we made. And finally I can do a wireframe view, which doesn't even differentiate the internal and external features. So these are the view options that are available to me. You can hide and show certain things. So in this case I can hide or show my different planes if I want to see my front, right, and top plane if there's any question as to how I've oriented the part relative to the planes. You can show certain things like coordinate systems or points. Really it's easiest to keep these off by default most of the time. You can also edit the appearance of the part. You can do the same thing off of a right click menu, which I prefer to do. And I can say appearances. And do I want to put appearance on just that face, on the Boss extrude that made that face, on the entire body, or the entire part? So I'll choose the entire part, and I'll go with appearances up here at this top menu. I can choose metal, and there are all sorts of different materials I can use. In the submenu I'll choose steel, and I'll choose a nice brushed steel. Now I have a pretty basic graphics on this setup, but if you are running a more advanced graphics, you'll be able to see the actual texture of what a brushed steel would look like. You can see all the individual channels that a brushed steel would look like. If you're curious, you can also look it up online if your SolidWorks looks like mine. You can also edit the background. Of course, we're looking at 3-point faded. One of the fun ones is you can do a courtyard, or you can do an urban background, almost looks like Detroit or something. Many of the backgrounds are kind of abstract with some colors, and many of them, especially as you go down the line, are just a photograph that you can move the part in front of. So you can, I don't know, model Santa's sleigh and put it in this picture so it looks like Christmas or something. So you have some options on the background, and this handles perspective. You can see that it looks a little bit more realistic, that the front is larger than the back with perspective turned on. You can do or undo shadows. You can see how the shadow goes away when I do that. Ambient occlusion, which is a little bit more realistic when you have really high graphics running. And cartoon, which is just another way of viewing things. So I'll go back to 3-point faded. Well, if I wanted to model something like this, let's call it a donut or a bagel in SolidWorks, or an O-ring or something of this shape, how would I extrude this? The answer is with a huge amount of difficulty. So instead of extruding, I want to show another way of being able to create solids that are specifically for rounded objects. To do that, I will open a part, and I start off by choosing a plane, Control 8, making sure I'm normal to it, and I'll draw a center line first thing. This is a technique known as revolving in SolidWorks, and it's very useful. You don't have to, but I will dimension my construction line. I'll make a circle. This will be the circle that makes the donut, and I'll give the circle a diameter of 2 inches. I'll give this, say, 1.75, and then for good measure I'll select a midpoint, select the center of the circle, and make them horizontal. So we're fully constrained. Again, very important to fully constrain. Now I can go to the Features menu because I'm ready to generate a solid. And one of the options here, next to Extruded Boss Base, is Revolved Boss Base. When I choose that, it automatically detects my center line and my circle. And what it's saying is, I'm going to use this as a center line, and I'm going to move this circle 360 degrees around this line and add material as I go all the way around. So when I click the checkbox, I've made, in this case, a donut. Now the Revolve has a lot of options associated with it. So when I edit the feature, I can choose 180 degrees if I want to. And I've made, I don't know, something that looks like an arch. So I can specify the amount of rotation I want within the Revolve menu. I can also revolve up to a surface or a vertex, which in this, it works the same way as Extrude. In this case it's not very applicable, but maybe I should do a example in case anyone is curious or doesn't understand. So I'll open up our friend the tape again. Alright, so if I want to create a sketch on this face, now obviously no tape holder would ever have this feature, so this is just for example only, because this is in no way realistic by any means. In fact, I'd venture to say that what we're making now is a pure example and no longer a tape holder. So if I give this 1/2 inch and I create a center line, say right along this tangent point. I guess that's not really a tangent point because you're not tangent right there. This would be an edge and this would be a tangent point. But at any rate, if I do a Revolve Boss Base, it recognizes my line and it recognizes what I want to revolve to. This is going all the way through the part. Of course, let's say I want to not only revolve it a certain number of degrees, like 185, and I can switch my side here, but I want it to be perfectly flat and not have this little edge right here. Instead of doing a blind, I can do an up to surface, which takes away my option for degrees because it automatically does degrees at the surface. And notice it stops at the surface and it curves with the surface, so it's not flat like a blind revolve would be. I can do up to vertex, so I can choose up to the height of this point, or I can respecify. It failed to revolve because of the angle of that certain vertex. I can do it up to that point there. So lots of options with the vertex. I can revolve offset from a surface, so it can match the surface but be 0.1, 0.2, 0.3 inches above that surface. So that's how the offset works. In fact, that's kind of a trippy looking feature if I accept that. Of course, no tape holder would ever look like this, but it makes for a decent example of how revolves work, rather. So as a quick example, what if I wanted to model something like this? I would definitely want to use the revolve. It would be the easiest way to do it. And if I take a section view, it gives me a nice cross section of what it looks like. So all I really have to do is sketch something like this and make a revolve line, and as this profile goes all the way around, I can add material and make it look like this. So if I make a new part, and I'll choose my front plane, Control 8, sketch, sketch, make a center line that's vertical. I don't actually need to constrain this. I often do for good practice. Then I can make that same profile that I saw. I can make that vertical. Choose this line, the outside, make that 12 inches. We'll make this, I didn't mean to add an angle there. We'll make this 1/4 inch. Make this 1/4 inch. This 1/4 inch. This 1/4 inch. 1/2 inch tall. It looks like I could put a 1/2 inch over here, or of course add in a relation of collinearity. Now, features, revolve. It recognizes my center line and my feature. If it doesn't recognize the center line, if it tries to do something silly like revolve it around this, you can always go up to axis of revolution and choose that. You can also say selected contours, and you can choose any features that you want to revolve if it doesn't default correctly. You can choose the thin feature, which is a pretty common feature. The thin feature allows you to do a certain thickness around your sketch. So if I go 2/1000 of an inch thick, you can always specify the other direction. And make it 2/1000 in the other direction. And when I section it out, you can see that it made it a hollow thin feature 2/1000 of an inch thick. So you can do the thin feature if you want to make some hollow features. Thin features also work on a non-closed sketch. So if I edit my sketch, try to rebuild it, the thin feature makes it so that I don't actually have to have a closed sketch like we talked about earlier. So the thin feature can be very handy in making revolves in that way. So that is an overview on how to revolve. Go practice this, make as many revolves as you can, get familiar with it, and I'll see you in the next video. Welcome to this next installment where we'll cover some sweeping skills. I want to start off with an example of one way to model something. Let's say that I want to extrude a cylinder and slowly use revolves to make that into, say, an S shape. Well, I'll start off by going onto the front plane. So I make a circle, and I can give it an arbitrary 0.5, and let's extrude. Let's say features, extrude, let's go 6 inches, and I'll reverse the direction. Now I can highlight this surface. Now this is kind of cool. I can go to the sketch menu and push sketch, and I want to draw a circle that would be equal, right there. And then I could give it a dimension, 1/2 inch, like I always do. But there's a shortcut, and this is as good a time as any to talk about it. While I'm sketching on this plane, I can highlight anything, I can even highlight this point if I wanted to, but I can highlight anything that is the shape that I want, and instead of sketching it out, if it already exists, I can just push Convert Entities, and it automatically makes a sketch on the plane. So notice I had this highlighted over here, and it projected that circle right on the plane and made it into a sketch. So Convert Entities is your best friend, because you can click even this side and say Convert Entities. So that is really handy going forward. So I'll push Control 8 and get normal here. Then I'll make a center line. And I'll give that 1/2 inch. And notice I don't have to constrain the edges because it's a center line, so it says my sketch is fully defined already. I can push Control 7, and I can do a revolve, just like we learned in the last video. And I can say 90 degrees and go the other direction. And then I can Convert Entities. I can extrude, and let's say I go 1 inch this time, and then I can Convert Entities. And make a sketch. And I can revolve. "90 degrees, other direction." There we go. And I can sketch, Convert Entities, extrude, and go another 6 inches. Oh, for that I'll probably have to go 5 inches. And I'll fast forward the rest. So here I've made this funky S shape out of a series of extrusions and revolves. Is there an easier way to do this? Of course there is. So after conveniently reviewing extrusions and revolves, in case you wanted a second glance at those, I want to tell you how to do a sweep, which is a lot less work than this. Let me open up a new part. And from here, just as before, I'll choose the front plane to sketch on, make a circle, same dimension of 1/2 inch. Now, instead of doing anything that would add material like extruding, I'll just rebuild to exit the sketch, and then I'll choose the top plane. Notice the top plane collides with my circle. In other words, my circle is sitting in my top plane, and the very center of the circle is in that plane. That is exactly what we want to do a good sweep. So I choose a plane that intersects with the sketch that I want to sweep, and I choose sketch. Now I can Control 8 and I'll make a sketch. I'll make a similar sketch to what I made before. And I'll give it some dimensions. First off, our initial extrusion was 6 inches long. This was 1 inch. This was also 6 inches long, which we have a relation that snaps it to the origin. So I can go and make this 1 inch and 6 inches. And from here, we had, if I add in a sketch fillet on these edges, and I can make that radius 1/4 inch. And there's a path similar to what we had in the model that we just created. Now I can rebuild, and I say Features, and there's the button for a sweep. It says Swept Boss Base. I click on that, and it gives me some options here. It says right here, what is the profile that you want? And I say I want this profile. And this next box is automatically highlighted, and it says what path. And so I choose this profile along this path. And I hit the green check, and we've made a sweep in SolidWorks remarkably like the one that we just made. I chose a different radius, so it looks a little bit different, but you can make an identical part to the one that we just made in a sweep, and it is a lot less work. And sometimes it's the only thing that will work. So there are some limitations. First off, if I go to edit the sketch, the sweep in the history tree has 2 sketches. The first one is your profile, the second one is your path. If I get rid of these radii, and I set these to be intersecting, you will notice that when I redo the sweep by hitting the rebuild button, it indeed can handle 90 degrees. But if I go edit my sketch, make some sketch fillets. So we saw that it can handle a 1/4 inch radius, and it can handle no radius or 90 degrees. If I make this 0.125 or an 1/8 inch radius and rebuild, I get an error. What is happening? What's going on is this profile is too large to be drawn over this small radius, so it can't compute. If I up this radius to say 0.49 and resweep it, the error is corrected. So that is something to keep in mind when we do this. Your radius has to be at least half of the diameter of the circle that you're sweeping. But it's not just limited to circles. I can edit this sketch, and I can say, hey SolidWorks, why don't you give me a hexagon? And I can dimension this. And rebuild. And notice I've got a hexagon that I've swept. So sweep is very powerful. It can take a lot of different input parameters. Finally, I can make a twist as I sweep. So if I specify a twist of 360 degrees, I can have a twisting profile going all through the swept path. So this is another skill to have on your tool belt when you do SolidWorks. Sweeps can make your life a lot easier. So I hope you've enjoyed this, and I will see you in the next video. Welcome back. I'd like to go over some of the additional skills you'll need in SolidWorks to be successful. And one of those is going to be the fillet. The fillet, of course, is a rounded edge. So for instance, if I want to make this edge round, click here and it automatically is rounded. How did I do that? Well, let's do it again. If I click the fillet button, it automatically allows me to select items to fillet. And I can choose whatever I want. Notice the preview went away, and that's because the radius is too large. A radius cannot exist with those conditions. So what I can do is respecify it down here, and I'll say 0.1. And I can continue choosing whichever edges I would like to be rounded. Of course, rounding an edge has all kinds of benefits in engineering. It uses, as you can see, less material, which means that your finished product will be lighter weight. It can often strengthen an edge due to there being no stress concentration on that curve. It can help with thermal robustness, where you won't get heat trapped in a sharp edge. So fillets are extremely useful for a multitude of reasons. And the beautiful thing is, I can keep on selecting edges, and SolidWorks can automatically fillet them for me. So the fillet is as simple as selecting the edges you want to have a fillet on and giving a dimensional characteristic, specifying a dimension. Likewise, if I choose this drop-down menu, a chamfer is also an option. Like a fillet, it simply bridges the gap with a straight line instead of a curve. So if I choose a chamfer of 0.1, I can specify a 45-degree angle or a 60-degree angle or a 30-degree angle, whatever I'd like, and a distance. And notice the chamfer automatically goes all the way around, since the edge that I have selected is a continuous edge. And there is a chamfer. Some engineers call it chamfer. Both ways of saying it are correct. If I have a part that I want to add holes on, particularly threaded holes, it can be very laborious to produce threads in SolidWorks. But there is a solution, the hole wizard. And in my practice of doing SolidWorks, let's say I wanted to add a threaded hole right here for some reason. Maybe the tape holder would have something that screws in on top. Well, I start a sketch before going to the hole wizard, and I'll put a hole in the center of that rectangle. And to do that, I specify where I want the center of my hole with a point right here. You can see that when I put a point down, it's just a little spot that specifies one infinitely small space. Now after I hit rebuild, I can go to hole wizard, and it gives me all types of holes: a counter bore, a slot, countersink, taper tap, a simple hole, a straight tap. Most of the time I end up using a counterbore or a straight tap, but you should know your application. I'll choose a straight tap. It gives me certain units. I'll stay with ANSI inch. Bottoming tapped hole is fine. And it gives me all sorts of diameters and thread pitches. So 1/4 inch by 20 threads per inch is a good size. I can choose blind, which means that when I choose the surface to put the hole in, I can blind how far I want my hole to go. Or like extrusion, I can choose through all, up to next, up to vertex, up to surface, and offset from surface. So maybe for argument's sake I'll choose offset from this surface by 1/4 inch. Now from here I can add, if I wish, a cosmetic thread, and I'll show you what that is. It gives you a few other options that are probably not relevant here. And so when I click the green check, it says you must select a point on the face to locate the hole. Well, good for me, I just put a point on the face, so I'll choose the point that I sketched in. First I must say 3D sketch. Choose a point and hit the green check. I can do as many points as I wish. And with that being said, SolidWorks automatically adds in a bottoming tapping hole. So if I go here, you can see exactly where the hole ends, 1/4 inch before the bottom face. You may notice that in the menu we selected to show a cosmetic thread. And that means I don't have to cut threads into SolidWorks in order for them to show. That saves a lot of graphics and processing because threads can take up a whole lot of system resources. But as you can also see, I don't see any cosmetic threads in that hole. So to get them to show, we're going to go to Options, just like we did in video 1. This button will appear different in 2014, 15, and 16. And I'll go to Document Properties, and I'll say Detailing. And from here, I can choose Cosmetic Threads, and here's the key, Shaded Cosmetic Threads. And then I'll head on down and select OK. And there is a cosmetic thread. The advantage to this is I can edit this sketch, and I can say I only want this to go to the halfway point of this line, and that will automatically relocate the hole between this edge and the halfway mark. And I simply rebuild the sketch and it remakes the hole. Now if I want to replicate this hole across the center of the part, that's easy too. First things first, when I extruded this I said blind, I'll switch it to mid-plane. And so now I have a plane that goes right through the center of the part. So all I have to do, instead of making 2 holes from the hole wizard and making 2 sketches, I simply say, just like we did in sketching, choose the mirror button. I can choose the front plane as the plane that intersects through the middle of the part, and I can reflect this hole across that plane. And notice the threads carry over as well. If this sketch gets annoying to look at, I can simply right click and say hide. So now I've got 2 cosmetic holes. One is a mirror image. The mirror image can be very advantageous because if I wish to go edit the sketch, if I would have made 2 holes, I would have been having to adjust the position of 2 different holes. By being able to adjust only one, the mirror automatically updates. And so I don't have to worry about the positions of other holes. Likewise, I can add a linear pattern of features, just like we did a linear pattern in a sketch. I can choose this line to specify a direction, and I can choose these features and add cosmetic threads all the way down, just like we had done before. Notice I haven't measured very much, and so these holes at the end didn't turn out very well. However, you can see that I have a series of cosmetic holes. Likewise, to get rid of this, I can simply delete the linear pattern. How about one more example of something else we can do in SolidWorks? You can go ahead and create a sketch on the front plane. I'll put a point at the end of the line, and I'll make it 2 inches. From here, I can go to Hole Wizard, like we've done before. This time I'll choose another straight tap, and bottoming tap is fine. Maybe I want to choose something a little bigger. Go with a 3/4 inch hole. This time I'll just say through all. And I'll go into my 3D sketch and choose the point that I have sketched out. And there's my hole. I will again add, under detailing, shaded cosmetic threads so you can see the threads that were cut. That can be a useful feature in knowing which holes have threads and which holes do not. And then what I can also do is add a circular pattern. And in that case, under direction, I can just choose anything that's circular, and I can add however many holes that I would like, perhaps 7 tapped holes. So it's an easy way to add holes without needing to sketch a lot. And you can see that that circular pattern works almost exactly the same way as in a sketch. So to go over what we learned, we'll do a fillet, and I can make that a 1/4 inch fillet if I'd like. And then I can add in a chamfer on the other side because I can. So between fillets, chamfers, holes, linear, and circular patterns, you've seen some good examples on how to use these things to make your modeling easier. I'll see you in the next video. And welcome. I want to do a real quick video on how to deal with errors in SolidWorks. Errors that, if you have been working with SolidWorks and practicing outside of these videos, you probably may have come across. So we'll go over errors and how to resolve them. First off, I'm making, say, a 3x3 square. And let's say I want to add a hole into this square. I'll make this 0.75, and I'll make this 1 inch. I can select the midpoint and make it horizontal. From here, I can extrude 1 inch, and I can do that without any error. But what if 1/2 inch away, you can see that the circle at the very center point hits exactly the edge of this line. Well, when I go to rebuild, I have a problem. And this is what we call a zero thickness error. Sometimes a little message will come up that says cannot extrude due to zero thickness geometry. I usually see that error message when I go to extrude. Unable to create this extruded feature due to geometric conditions. So What's happening here is that SolidWorks knows it needs to add material anywhere between this line and this circle. And as it comes in, it hits a certain point where it doesn't know if the material belongs there or not. And it's impossible for SolidWorks to figure out. So it trips a zero thickness error. I can easily resolve that by saying 0.50000001, and just that little bit of space enables SolidWorks to know that it should add material. So when I go to extrude this, I have just an absolute thin ribbon of material here, and SolidWorks can indeed extrude. I likewise can come across this same error if I were to add a corner-to-corner rectangle. Without even constraining this, you can see that I have the exact same situation where at this point SolidWorks doesn't know if it should add material or not. So when I go to rebuild, it gives me that error. So these are things to keep in mind when you have problems with geometric conditions or zero thickness. Just move things over by negligible amounts if you want them this way, and they'll fix. And this is such a minor change in your sketch, it wouldn't even reflect a manufacturing tolerance. With that, I'll see you in the next video. I'd like to offer a conclusion on the SolidWorks course. SolidWorks is a parametric 3D CAD modeling system. It starts with a sketch, and when a sketch is generated, it can produce a solid. Solids can produce several things like assemblies and engineering drawings. Sketches should be fully constrained, and they can be fully constrained with the use of relations and dimensions. Sketches can utilize patterns like circular and linear patterns. Solids can be formed by extruding, formed by revolving and sweeping. And extra features can be added like fillets, chamfers, and circular patterns and features in solids. I hope this Allison course has been beneficial to you, and I'll look forward to seeing you in another course. Thank you.